If a body of mass 1 kg falls on the earth from infinity, so that means, let's take is the earth. So as we know, earth have a gravitational field. Now one object is falls from infinity. From infinity, one object is falls on the earth. Okay, it attains a velocity v and the kinetic energy, say k, on reaching on the surface. The values of v and k respectively. So here the radius of the earth and the g value is given. Now I hope you remember about the escape velocity. What do you mean by escape velocity? We want to write the same concept of escape velocity, but here they have a little change. What do you mean by escape velocity? If you want to projected an object out of the earth to infinity, or you can say out of the earth and the gravitational field up to a distance that the gravitational field is not acted on the object. This is called the escape velocity. So if you want to write the same logic here by writing the energy conservation, that is kinetic energy initially, because the potential energy, as we know, that will be minus gmm by r for a gravitational field. So we can write this, let's say the kinetic energy, initial kinetic energy at k dot e I plus potential energy initially equals to the kinetic energy final, that means after reaching on the surface of the earth, plus the potential energy. So we can write F as a suffix. So as we can see, the object is coming from infinity and it is given 1 kg false. It is not talk about any velocity, initial velocity. Then we can easily write as a kinetic energy is 0. Now the potential energy, as we know, for gravitation, it will be minus g m1 m2 by r, where r is the distance. So here the object is falling from infinity. So we can write minus g into me, where me is the mass of the earth, me, and the particle mass, say small m. Then we can write a small m by r. So since the object is coming from infinity, so we can simply put infinity here. Equals to, so after reaching on earth, it have a velocity v. So we can write half m v square plus minus g m e m. Now it is given on the question that it reaches, or it reaching on the surface of the earth. So that means we can say at this position, so this is nothing but the radius of the earth, that is capital R. Now we are going to write the expression of v in terms of the other quantities given here. So this quantity will be 0 since 1 by infinity is 0. So v will be, so minus g will be going to this side. So in LHS it will be positive. So small m cancel out. Then you can simply write g into me by r root over 2 will be multiplied. So 2 gme. Now as we know that small g goes to gm by r square. So therefore gme equals to g into r square. G into r square and r cancel out. So simple 2gr. So the value of r and value of g is given to the question. So we can write equals to 2 into g 9.8 into 6400 kilometer. That means 10 to the power 3 root over. So if we solve this question, then we have the value 11.2 km per second. Okay. So this is the velocity that is given. So that means according to this answer 11.2 km per second, 11.2 km per second, that means option 3 is wrong, option 4 is wrong. Let's see about the energy that will give you the answer. So kinetic energy equals to half m v square. So let's put the value half m value is given as a 1 kg. So 1 multiply with v square, it will be 11.2. Since km So it will be 10 to the power 3 square. So if you solve this, you will get 6.72272 into 10 to the power 7 joule. So that means according to the answer, option 1 is right. Thank you.